In this video we are going to talk about Kirchhoff's current law, and it is one of the important law in the physics and circuits. So let's begin. What does it says? Well, this law comes from the conservation of charge. So let me draw some pictures. For example, consider this as a Gaussian surface S, and some currents are entering. For example, this one, I1, I2, I3, and I4 is leaving this surface. So entering currents should be equal to the leaving currents. So because of the conservation of charge, this condition should be satisfied. So I1 plus I2 plus I3, which are the entering currents to our Gaussian surface, should be equal to I4, which is leaving. So in the next slide, we're going to see an example of this law. So here in this example, you can see some Gaussian surfaces S1, S2, S3, and S4. So in S1, the currents are entering. Well, there is no current entering, but there are some currents that are leaving. So I1 plus I2 are leaving, equal to entering currents, which are, there is no, so it will be 0. And for S2 Gaussian surface, the entering currents are the entering current is I1, and it is equal to I3, which is leaving. And for S3, I3 is entering, just I3. Which currents are leaving? It will be I4 plus I5 plus I6. And for finally S4, the currents which are entering are I4 plus I5, equal to the currents are leaving are I7 plus I8. So in general, KCL says that the amount of currents that are entering to the Gaussian surface is equal to the amount of currents leaving the Gaussian surface. And that's it for this law, and thanks for watching.